In this example, I'm going to solve this linear system using elimination. So the first thing we need to do is make sure that both of these equations are written in standard form. So I have the x and the y on the left side and my constant on the right side. So on this first equation, 7y equals 8x minus 11, I need this 8x to bounce over to the left side. So I'm going to subtract 8x from both sides. And I'm going to rewrite that first equation as negative 8x plus 7y equals negative 11. And it's plus 7y because the 7y is positive. So now let's take a look at the second equation, 3x. But then the 9y is on the right, so I need to bounce this 9y over to the left side by subtracting 9y from both sides. And that's going to equal negative 15. And again, the reason I do this is so that my x's and my y's and my constants are all vertically aligned as like terms. Okay, so I'm going to go ahead and put my little bars here, denoting that I'm going to use elimination here. So now I need to decide, are we going to eliminate the x's or are we going to eliminate the y's? Well, when I look at the x's, it looks like the coefficients have opposite signs, but 8 and 3 are not the same number, nor is 8 a factor of 3 or 3 a factor of 8. So if we were to eliminate the x's, we would not be able to just multiply one equation by an integer constant. So let's look at our y's. We do have positive and negative, so we know we have opposite signs. This is a 7 and this is a 9. Once again, 7 is not a factor of 9 and 9 is not a factor of 7. What this tells us is that we're going to have to multiply both of the equations by an integer factor in order to kind of accommodate this idea of eliminating one of the variables by having equal in number coefficients but opposite in sign. So when I look at my x as 8 and 3, these numbers seem to be a little bit smaller than 7 and 9. So I'm going to work to eliminate the x's. So the least common multiple between 8 and 3 is going to be 24. Or you can just take it and say, well, I'm going to put the 3 up here, bring the 8 down here, and when I multiply them, negative 24x, positive 24x. So that will get what we need, and then when I add these equations, then the x's will cancel. So let's go ahead and take a 3 and multiply this 3 through every term in the first equation. So negative 24x plus 21y equals negative 33. Now let's take the 8 and multiply it through every term in the second equation. Positive 24x minus 72y equals negative 120. So now as I add these two equations up, my x's will cancel. My y ends up being a negative 51y, and my constants are negative 153. So a quick division by negative 51 will show us that the value of y is going to be a positive 3. So once I know the value for one of the variables, I'm going to go ahead and plug it back into one of these original equations. So let's go ahead and do it in the second equation where 3x equals this business. So 3x equals 9 times y, which is 3, minus 15. So 3x equals 27 minus 15. 3x equals 12. So when I do this little division, I'm going to notice that x equals 4. So now that I have the value for x and y, I can write the solution as an ordered pair, 4, 3. And this ordered pair 4, 3 now serves as the solution to this linear system.